Hello everyone, my name is Ajay, and in this section we are going to talk about the AWS network. So what is AWS network? To understand it better, we need to take a look how the global infrastructure of AWS looks like. So on my screen you can see there are multiple regions and there are some regions those are coming soon. So these regions are basically the location geographic location where you are going to have multiple data centers. When we say data center, so data center means you are going to host your application, you are going to have some sort of connectivity to those data centers over the internet or maybe from the private lease lines. Inside the data center, you are going to have the underlay network and your overlay network. Underlay network means all the physical equipments like routers, switches, how they are going to be connected from each other with some sort of physical media in between. And top of that, you are going to run some sort of the hypervisor, which basically hosts your VMs. If this is my first VM, this is my second VM here, how these VMs are going to talk to each other without being aware about all these underlay network. Let's take a look on the comparison when we compare AWS network to Microsoft Azure network. So AWS, it is based on virtual private cloud. We call it VPC. And in Microsoft, we are going to call it virtual network, which is VNet. They both exactly does the same thing. You're going to create your subnets, allocate the IP ranges, etc., etc. Scope, this VPC is regional. It is the same concept in Azure also. However, when you talk about the Google, it is going to be the global. So you can create VPC, which is going to be the global service. Geography and regions is region based. Yes, you're going to have the availability zones. Yes, which is true. Availability set. That's something extra what we see in Microsoft Azure. It means how you're going to place your VMs to achieve higher availability. It is based on some sort of the fault tolerance and the update domains. Then your pairing, it is going to be VPC to VPC pairing. That's the same exactly concept exists here as well. User defined routes, you can specify in AWS, the same thing you can do it in your Azure also. Subnet, CIDR or CIDR, derived from VPC CIDR, it is the same. Then on top of that, security functionality, you are going to have network ACLs and security group. So network ACLs basically you can place top of VPC and your subnets. It's the same thing here also. And then you are going to have the security groups. Basically those are the security groups or the firewalling which you basically configure on your end host. Let's take a look how the cloud network may look like. So you're going to have core layers, aggregation switches, and edge switches. For higher availability and for higher throughput, your connectivity will look like this. So in this example, we can see this you may call leaf switch, this may you call spine, and this is your core switch. So leaf switch, it is connected to all the switches, all spine switches, first, second, third, fourth, and then each spine is further connected to all the core switches. That's how you achieve the redundancy. This is just a simple. I'm not saying AWS network will look like this, but this is just a concept. How we achieve the availability and redundancy. So for example, these are going to be pods. One pod, second pod, third, fourth. And they are going to be isolated in terms of power, in terms of connectivity. So for example, if this pod goes down, you still have your 75% capacity up. If this goes down, you still have your services running here and here. Let's take a look how the underlay and overlay may look like in a typical network scenario. So you have a switch, you have a PC, and these switches are connected from some sort of the physical media, which we call network, and this is my PC2. So PC2 wants to talk to PC1, or maybe PC1 wants to talk to PC2. How it may work. So these switches, either these switches should support some sort of the VTAP configuration, which you can do. So I'm referring to VXLAN here. So VXLAN is one of the overlay technology which we can use. So this PC is connected to this switch, and this PC is not aware about this underlay connectivity. You are going to have a VTAP configured here, VTAP IP, and another VTAP IP is going to be configured on the second switch. When PC1 initiate any connection to PC2, it is going to be intercepted by VTAP, and VTAP knows this PC2 is sitting behind a switch, and I'm aware about the VTAP address, which is going to be VTAP2. So I'm going to form a tunnel over this underlay network, and then all this communication go through. In another scenario, you might have some sort of the fabric running. So all these switches are part of that fabric, and I'm running the underlay network over there. I might have some sort of hypervisors running in my network, and those hypervisors will have some sort of internal logical switch, which we call the V switch. It's a virtual switch, and you can also bring your VTAP functionality to V switch. So instead of these switches, they are forming VTAP to VTAP connection, your connection will be directly initiated from VM, and VTAP is here on hypervisor. It will be intercepted, and this VTAP on hypervisor, it is going to initiate a VXLAN tunnel to another V switch. That's how your communication will work. Now we understand how the overlay networking works. Let's try to understand the concept, how this virtual private cloud is formed, which we call VPC. So you're going to have the region, and your VPC is basically tagged with the region. It means it's a regional component. Under that, when you're going to create a VPC, that can expand basically to all the edges under that particular region. So you're going to have availability zone 1, availability zone 2, and then you can define your subnet, and where you want to host that particular subnet, that is going to be the choice you are going to get while creating the subnets. So my first subnet, it is under the AG1. My second subnet, it might be under AC2. Everything starts with CIDR in VPC. It is going to be some sort of range. First time whenever we create, or you're trying to create VPC, the first default subnet it is already allocated, which is going to be /16 or something. However, you are going to have some choice, whatever the IP range you want to define, you can define it. And then this CIDR, you need to break into multiple subnets. So here in this example, I'm saying I want to create a private subnet. Maybe in this subnet, I'm going to host my database services, which should not have any connectivity at all to outside world. Then you are going to have second subnet, which I'm calling it as a public subnet. I might host some sort of the web services here, which should have connectivity to outside world. And while creating these subnets, you need to find out, or you need to define how many hosts you are going to have within that subnet. Based on that, you can define your subnet mask. Once you have those subnet masks, there are multiple things The way you do the networking on-prem, you can do very similar things here on AWS Cloud. The very first thing after creating the VPC and putting some resources inside your subnets, you need the internet connectivity. For example, you created a virtual machine. You cannot access a virtual machine without the internet. Or this virtual machine cannot reach out to outside world, maybe for downloading some sort of the patches. So this is going to be your internet gateway services from where you can reach out to your internet. The second thing you might need, maybe you are running some load here in private subnet, and these machines, they want to do or download some sort of the patches from the internet. How they can reach? Since we have said this is a private subnet. So what you can do, you can create a NAT instance that is going to be some EC2 machine. It's a kind of the VM with spatial images. You can build it, that will be managed by you, and then you can route your internet traffic from private subnet to your public subnet, and public subnet is already connected to your internet gateway. That's the second use case. In the third use case, you can go for NAT gateway, that is going to be the AWS managed services. It does exactly the same what you can achieve from the NAT instance. That is the third use case. In our fourth use case, you can also connect this VPC network to on-prem. So what you need to do, you need to create a virtual gateway, which is going to be attached to your VPC, and then you can run the virtual private network on top of that. In our next use case, instead of relying on internet services, you may want to have some sort of dedicated bandwidth with the high throughput connecting to AWS Cloud. You can go for direct connect. So you can use direct connect connectivity, and you still need virtual gateway to connect your VPC. In the next concept, you might have multiple VPCs. This is my first VPC. You might have same VPC created within the same region, or you might have VPC in a different region altogether. However, AWS provides you a feature where you can do connectivity between this VPC without introducing any extra services or hardware. So that is called VPC pairing. You can pair it within the region and to intra-region as well. The next use case, which we are going to call it endpoints. So for example, services within the VPC, they want to access S3 services, which is sitting outside of VPC. Technically, your flow should go from the internet gateway, which you don't want. I don't want to go to internet while accessing another service which is sitting on AWS Cloud. So you can create your endpoints, and these endpoints you can directly connect from this VPC, and it connects to S3, and that is going to be infrastructure or the connectivity within the AWS infrastructure. In our next use case, we are going to introduce AWS Transit Gateway. So that is kind of the router which connects multiple VPCs, and same time you can also connect your on-prem. You can also bring AWS Network Firewall, basically to inspect all the traffic which might be between your VPCs, might be between your subnets. So this is a kind of the firewall servicing which you can introduce in your network on the cloud. The next thing you can introduce is going to be the elastic load balancing. So AWS provides your classic load balancer, your network layer load balancer, which is NLB, and then you are going to have ALB, which is your application load balancers. So basically, you can host this load balance and do some sort of load balancing for the resources which is sitting in your public subnets. For example, it might be the web application, so you might have multiple nodes sitting here. You can do the load balancing. You can also utilize AWS IPAM services, basically to manage your IP ranges. AWS also gives you an option to bring your own IPAM. So it's up to you what you want to use. There's one more option which you can use to make your VPCs more secure, that is going to be network ACLs. So you can use these network ACLs to restrict what kind of traffic we should go in and what kind of traffic it should go out. For watching, I will see you in the next video.